Okay, respected expert, esteemed colleagues, and my dear participant, very good evening to all. It's great pleasure to introduce today's distinguished expert for day 5, session 1, Dr. Surajit Debnath, who will be delivering expert session as a part of this AICT ATAL Faculty Development Program, AIML application in mechanical system. Dr. Debnath is currently serving as Vice President Institute Innovation Cell at Women's Polytechnic AICT, which is affiliated to Tripura University. He is a selection grade lecturer, associate professor scale in the Department of Medical Laboratory Technology. With more than 20 years of experience in biomedical research and teaching, Dr. Debnath is a passionate technologist with strong interdisciplinary exposure. He has participated in and contributed to academic and research activity at reputed institutes across Europe, including Germany, Denmark, and UK, as well as leading ASEAN and Indian institutions such as AIMS, IIT Kharagpur, IIT Guwahati, and research centers in Hong Kong. Dr. Debnath is a recipient of Young Scientist Award for prestigious national agency, including DBT, DST, CSIR. He has also received Tata Trust grant for continuing medical education course at Royal College of Pathology, London. He served as a reviewer for several SC and Scopus Index journals published by Elsewhere, Springer, and Biomedical Central. In addition to his academic responsibility, Dr. Debnath actively worked as a consultant to multiple biotechnology companies across northern and western India. He has conducted numerous workshops and invited talks, served as a session chair at international conference, and delivered expert lectures at national and international academic forums. Dr. Debnath is currently guiding international students from Russia, Turkey, and West African countries for research internship and has also filed 2 patents in India in the domain of biomedical research. With this small introduction, we are indeed privileged to have such highly accomplished academician researchers and innovation leaders with us today. So I now request Dr. Surjit Debnath to kindly take over the session. Thank you, sir. Thank you. Please start.
Yeah, thank you for the introduction. I am audible, sir?
Yes, sir. Yes, yes.
Okay, at
Yes,
any
sir.
point of time, if something goes wrong, please let me know. So,
Yes, sir. Yes.
good evening to one and all. I should forward my this thing gratitude to the yeah. Hello, this is audible, right? Is it audible, sir?
Yes, sir. Yes, sir. Now it is audible.
Audible, and the screen is visible, right?
Yes, sir. Yes, yes, yes.
Okay, so the my domain is basically in biomedical research and development, and my fascination with mechanical systems started when I was a student and before PhDs. When I first time used ELISA machine. So ELISA is a device which will help to detect a very minute quantity of metabolites, which uses a mechanical system, shall I say a robotic arm, which will automatically inject solutions at a micromolar level and put it to this thing, this what do you call is in a reaction vessel. So my in our this thing with robotics and mechanical systems started from that point of time. Subsequently, we developed many these things huge interest in this particular domain, and today we are trying to build teaching learning tools which are backed by new technologies, new microprocessor based technologies, that is AI and machine learning, to make studies more lucrative, more streamlined, and more this thing more interactive for our students, those who are in a teaching profession like us. These tools, I will demonstrate two of the tools, and we will also discuss that how exactly these tools were developed. So two demonstrations and one small hands-on to understand that how these predictive models work. We will do those things in today's session. So in the first this thing, if we see that robotics is rapidly reshaping biomedical care, when it's doing tremendous things when it integrates multiple different new technologies, AI, machine learning, deep learning, then it gives a tremendous magnitude of development for biomedical research and patient care. The outcomes of improved patient care are excellent these days, and we will be discussing those things, that how mechanical systems controlled by artificial intelligence and machine learning are streamlining the repetitive tasks, and how they are automating it. So those things we will be discussing a bit. So if we look at the global scale, that why these technologies are very important these days. So global medical robotic market was already valued in tens and billions of dollars in 2024. Just after the COVID, there was a rapid boom in automated systems for medical purposes. And one more aspect is that because we were able to generate a huge amount of data, the ability to analyze large data and then eventually prepare a protocol which will automate a mechanical system in a way it should. So those things have helped us to gain more traction in these particular domain. So it increased the mechanical precision, the accuracy and reliability of robotic movement was been increased significantly post COVID. Then there was a domain of data driven intelligence. Many decisions the machines can take by themselves at a smaller scale, not in a large scale like automated vehicles and things, but at a smaller scale also, which is very impactful in healthcare research. Then automation of repetitive tasks. As I have said, we had a machine. I could not show it to you because many of you are from classical mechanical background and not from biomedical. So there is a machine which is known as ELISA. It does very precise analysis at a micromolar level. For example, if there is a hormone to be determined, and the amount of the hormone in the whole body is approximately 0.6 millimole. So in order to identify this particular thing in one drop of blood, it needs a very precise analytical environment. To provide that analytical environment, we do have a machine called ELISA, which uses a robotic arm to aspire the sample and then mix it with blood and then eventually read the data as well. So these automated systems have helped us to do repetitive tasks very significantly. I give you a small example. Approximately like 10 years back, if you wanted to do a blood test, high level blood test, for example thyroid screening, you could have spent approximately like 1500 rupees. These days these tests are available at 500 rupees, 3 times reduction. So how this thing has happened? Because we have automated the repetitive task. The person should not stand continuously near the machine and do the testing. It's all takes place automated systems. Then enhanced clinical capability. The doctors are also very this thing helped by these development in the automated systems, improved patient care, which is the ultimate goal, and it has reached a significant point these days. So since this is the background in biomedical robotics, there must be good impact in generating teaching learning tools also in this particular domain. So we are fortunate that we received a substantial grant from government to design a system where we can build teaching learning tools for multiple different domains, including biomedical robotics. So we'll demonstrate two tools, and one of them is a simulation tool, where we shall see that how very simple robotic methods can be taught to very small students also. These tools has been prepared by our in-house facility. So there is a huge opportunity in edutech infrastructure development also, where we can integrate AI and ML, artificial intelligence and machine learning, to generate tools which will help our students to understand these critical concepts in a very very lucid manner, very interesting way. So this is this thing. Recently there has been many reports that why we should integrate artificial intelligence and machine learning in digital learning processes. So McKinsey is a big company which does a lot of third party market research, which gives us much more confidence that the way we are doing it, we are doing it in a correct way, because every day or two we are developing some or the other tool in order to for our clients. Our clients are by and large small organizations, for example some edutech companies which are smaller, but they are trying to enter into these particular domains. So they are connecting with us, and we are building digital tools for them. So BCG, again one consulting group, they are also telling this thing very rapidly, that gradually digital integration in teaching learning process will be very big, and therefore there is a huge opportunity for small laboratories like us, where we can deploy artificial intelligence and machine learning to build digital tools for our next generation of classrooms. So presently what is our classroom architecture? We will have a smart board. We will either have some video lecture, or we can have some PowerPoint presentations. But the next teaching learning method will be how it should be completely interactive. So students interactive in the sense, not looking at video then making a note. This is a kind of interaction, but we are talking about interaction at the next level. We will demonstrate our tool, and you will understand that what exactly we are trying to build here, where we will be not only designing this thing so true digital transformation is education is what? True digital transformation will be a completely new method of teaching, where teaching learning will be much more interactive. So whatever you will be speaking, you will be demonstrating on screen. That means every class will be a lab, and every class will be a practical, a component of practical teaching will be there in the class. Even in the theory class also, you will have some practical aspect, that is interaction using a tool. That usually what we do in our labs only, we use a tool and demonstrate. So here what we are trying to do is, each and every class should be should have a method where we will have some kind of interaction. So in medical robotics, if we see, the highest impact has been generated in medical robotic surgery, because it's very lucrative also. The government of India has also initiated a pilot project, which is based on telemedicine kind of thing. So in that case also, remote robotic surgeries are Till now this has not been implemented in a bigger scale, but there is huge opportunity. So why not build teaching tools around it? Why not teach our students that how biomedical robotics will be shaping in next couple of years, and how these mechanical systems are evolving day by day, at least in my domain. In every domain it is there, because automated vehicles and these things are there, then drone technology, everything is there. But in medical field, these applications are highly impactful. Means I give you an example. For example, an automated vehicle may not be the need of the hour. It could be an luxury. Okay, you go to New York and you enter into a automated taxi, where by your voice recognition you can give instruction to the taxi and it will take you to your destination. It's a luxury, it's a kind of fancy thing. But biomedical robotics is no longer fancy, it's a need of the day. So we'll come to those points, that how this revolutioning of surgery has taken place. I will not go to much detail in this particular domain, because multiple other these things are there to be touched. So here, as you can see, that there is a thing called Da Vinci system in most of the tier 1 5-star or 7-star hospitals. These systems are there. These are basically for cancer surgeries, where it is completely automated. The maneuvering is so precise that the doctor will only use a handheld device through which the tissue will be exposed for radiation purpose, and the radiation will be so precise that it can even impact a single cell from where a cancer can be originated. So those things are high level of biomedical this thing engineering. Let's not get into that, but this thing is on our face. So biomedical robotics and biomedical mechanical systems are gaining high traction day by day. So this is the market growth, why this is lucrative, and why we are building not directly a robotic system, but a teaching learning platform around medical robotics. So healthcare robotics market growth is significant. Healthcare service robots as well as rehabilitation exoskeletons. For example, a person do not have a limb, a leg or hand is not there. So in that case, how a next level, or shall I say advanced auxiliary device, or shall I say that an extra mechanical limb can help the patient in order to do his day-to-day activity. These things are developing traction day by day. And one more this thing which is developing, we have not entered into this, but we are trying to get in, that how surgical automation can we go to the next level. So we are exploring and we are seeing every day what are the clinical trials that are going on in AIML, enhanced surgical autonomy, and in couple of years it will have a very good this thing also, because this is also the need of the day. For example, the Da Vinci device costs near about 1 crore, but to build a primary level hospital and to deploy healthcare experts there, that is similar to a PG, a postgraduate doctor in a rural hospital, the cost is recurring. Recurring means every day, every month costs are there. But if we can deploy these automated tools in remote places, so there will be a very great opportunity in this particular domain. We are not going there, but we are only going to the teaching learning part of it, that how my lab is using artificial intelligence, data science and machine learning to this particular domain. So why not talk a bit about the evolution of artificial intelligence. So what exactly happened is, we already had the method to handle amount of large data set to identify hidden information present in it. Okay, so let's say that uh, we are trying to estimate that what will be the projected cost, or some kind of estimation we wanted to do. So we already had that ability, but when we are talking about data science, we are talking about a large amount, very large amount of data. For example, n number of sensors, what kind of data they are gathering, and what is the uh, insight in this data. So this ability has been generated recently, and on this background, we have developed a thing called machine learning. Machine learning means a method where we can able to teach the machine how to learn. So it is similar to human learning. I'll come to those points later on. For example, machine learning can have two different aspects to it, supervised and unsupervised. So supervised learning is something like that. For example, my younger kid is there. If I tell my younger kid that do not touch the flame and it will burn your finger and it will be painful, she'll listen to me. So this is a supervised learning, and one is unsupervised learning. If I tell my elder kid do not touch the flame, she will not listen to it. She'll put her hand onto the flame and she'll understand that it's hot. Let's not touch it any further. So both kind of machine learning has some pros and some cons. We will come back to those things. On this basis, the superior learning models are called artificial intelligence. We will come back to those things also. So now in our lab, what we are trying to do, we are trying to build some interactive tools to teach our biomedical students about medical robotics. This is how we at first developed our interest in this, and then we found out that it's this thing, because we used to see the podcast of this thing, the big thinkers of today, of some bigger automation companies. So we came to know that sooner or later we should teach our students not only to the basic principles of biomedical devices, but also how to automate them. At least give them some basic idea how these models can work. So from that thinking, we developed several tools, and before developing these tools, we did a thorough market research. We talked to several institutes. Similarly, our interaction with Zeal was also based on this thing only, and eventually we did some surveys, observed many patterns, and eventually we developed a tool which we will demonstrate today, to give you an understanding of how robotics can be helpful in healthcare. Now, before going to these things, very important aspect is, in this particular tool, what we did was we analyzed the clinical trials that were had during this last couple of years, mainly 2024-25. So what happened? Now, why we have this thing for what do you call is why we have called for this clinical trial analysis? This is also very important. So you will understand that if something is growing, if a particular domain is increasing in impact, your this impact will only be visible in the market. Now, what are clinical trials? Clinical trials are tests which are not only basic research. In basic research, what happens? We end up doing many research for the sake of publishing something or get some patent done, but eventually there may not be some product market fit. Now, what is a product market fit is, you may be interested in something, you may be highly excited with something, but eventually what happens that this is not a solution at all. Your lab is working for something, but there is no monetary value out of it. So government of India as well as AICT is trying to push this particular thing, that in each and every lab there should be some amount of intellectual property which is marketable, not only for the sake of doing this thing, intellectual property in that in terms of publishing papers and things like that. There should be some real outcome in the market. So clinical trials are the next level of this thing. So one company or one lab has designed something and they have tested it with patients. So this gives you a clear idea of product market fit, and therefore what we did, we could have analyzed whatever research paper has been published in IEEE or IEEE Explorer or something. We did not do that. What we did is we only studied the clinical trials with devices which are integrating robotics. It may or may not integrate AI or ML, but it must have integrated some amount of automation in a mechanical system. So we analyzed all these this thing, what do you call clinical trials. There is a database which is a government database which houses all these clinical trials, and we identified all the clinical trials, and one by one we studied everything, and eventually we generated a digital
Hello, hello, hello. Sorry, you are not audible. Okay. Yeah, just wait, just wait. Maybe disconnected. Just wait. Oh, oh, what a- Just wait. Expert is disconnected. Just wait. He's joining.
Hello, am I audible?
Yes, sir.
Hello,
Yes,
is
sir,
it
you are
audible?
audible. Yes, yes. Please share your screen.
Okay. I am very sorry that I could not this thing. There was a sudden power loss in the institute. Anyway, I'll be
Yes,
demonstrating the
yes.
tool later on. But before that, let me this thing share my screen.
You can share screen.
Yes. Show caption, meeting settings, video statistics, disconnect audio, chat. How to where is the option to this thing?
Sir,
Share.
just wait a minute.
Please.
Let me make post.
Please.
Sir, you can share screen now.
Okay.
Please check.
No, still it is.
You can share screen, sir.
I am joining from the phone browser, not from app.
Yes, no issue, sir. You can share your phone screen. You are co-host now.
Okay, I'm just checking it. How to do this? Meeting settings, show options.
Go to more options. Sir, please go to more options.
More option.
You will have share option.
Acha. I'm leaving it and I'm getting it one more time.
No issue, sir. Through mobile also you can join.
Where?
On main page. Yes, go to more options. Near to
I have gone to more option then.
You will observe share one option, share.
I am only seeing chat, show captions, meeting settings, video statistics, help, disconnect audio. Only this much I am getting. Therefore, I'll once again rejoin. Let's see. After you have changed some setting, no? I see that. Just hold on.
Hello, Ritapuri sir.
हाँ
Sir has joined or not?
होत आहे जस्ट वेट तिथे नाव बदललं ना तर परत त्यांना कोर्स करावं लागतं त्यांना
Yes. Okay.
येस सर अरे वेगळंच आहे कोणतरी परत लेफ्ट झाले बहुतेक
Retapur is sir. Sir, I joined. Is on you?
नाही
Yes. Okay.
नाही join झालं आणखी.
Retapur is sir.
Yes sir. Yes.
Hello. Sir, I joined. Please make him host.
काय नावाने join झाले परत?
Dr. Devnath.
नाही हो, नाही join झालं. मी वेगळंच कोणाचा कोर्स केलाय.
I know.
नाही दिसत ना.
In participant list, you can search Devnath. Make him a co-host.
No, I am searching, but he is not joined. Just I will make a call to him.
Hello, sir. Hello.
Yes. Yes, sir. Yes.
So I don't understand that why this I cannot share this thing.
Just what happened if you once you left the meeting, your co-host. Have you joined meeting? Just wait.
I have joined the meeting, but I am not finding the presentation. This thing, how to present it?
Just wait. I will make again a co-host. I'm not getting why your name is not.
I mean, I am seeing Dr. Debnath. I have written Dr. Debnath, sir.
Okay.
Dr.Debnath.
Yes. Okay.
Have you found it?
Yeah, just now I will make you co-host. Now you try to share the screen. Now you try, sir.
I am only seeing these 4 options. Cancel.
Please, you WhatsApp me PPT. I will share.
That only I have to do now.
Yeah.
Okay. Yeah, sir, tell me. Wait. Sir, tell me your WhatsApp number.
95
95
45
45
90
90
8970.
Hello, sir.
Yes, sir. Are there some technical issues, sir? Please wait. So just I have sent hi. Devna, sir.
Ritapare, sir, your voice is not audible.
Okay. Am I audible? Jagtap, sir.
Yes, it is audible. Debnath, sir, have you joined through a mobile or a system PC?
Sorry.
Hello.
Actually, sir, have joined from initially
Ritapare,
system.
sir, voice is very low.
You just wait.
Ritapare, sir, hello.
You just Jagtap, sir, please wait just 2 minutes.
Okay. Otherwise, I will show one demo, how to share the screen through mobile.
No, I think that app is not installed. That's why
Okay.
you might be facing some issue.
Okay.
I will share from here.
Okay. No issue.
Yeah, please share, sir.
Is it visible, sir? Now?
Yeah, it is visible. Sir, just go to some next these things. These things we have already discussed. That we are working on a tool which will help us to understand that how mechanical automation will helpful in biomedical applications and health research as well as applications. And eventually we have Sir, go to the hands-on slide. One more slide is there. Please go to the next, 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 next. Yeah, this one. Okay. So what we are trying to no before this particular slide, before this slide, sir. Yeah. So what exactly we are trying to do is we were trying to build one tool which will help us to analyze the recent developments in biomedical robotics. And in order to do so, what we exactly did is we analyzed all the clinical trials that has happened from 2024 to 25 to figure out where is the best product market fit for robotic applications in biomedicine and health sector. So what we did is we identified all the clinical trials that has been published during this particular year, and many clinical trials were based on rehabilitation. Sir, go to the next slide. So many trials were based on rehabilitation, and some trials were also on robotic surgery. So then we also understood one thing, that at a small scale also robotic applications can be helpful in health research. So since the system has been compromised from my end, because all on a sudden there is a power loss, I could not demonstrate, but I am hopeful that I'll be surely able to demonstrate is during the last part of the session. And if not possible, I'll be sharing the videos of that particular demonstration to our coordinator sir, who will eventually share those things to you. Sir, go to the next slide. So why we have decided to do the clinical trial analysis? Because it will give us the idea that how automation in robotic system, automation in mechanical system is not only in pen and paper, but exactly in the market. So what happened before any device to get into the market or get into the consumer, they should have a clinical trial, even for medicines also, as well as for biomedical devices also. So in that case, what happens? If we identify those clinical trials, we'll understand many things. The one thing we'll understand that which is the best product that will be recently available within some time, which integrates mechanical automations in medical purpose. So therefore we did this analysis, and I am hopeful that I'll be able to demonstrate that particular tool, which is highly interactive and very interesting to study. Now this particular slide, which currently is on the screen, indicates how predictive analysis works. So predictive analysis, which is integral part in automation. So automation can only take place, that means orchestrated automation. That means the automation that we require to do the day-to-day task should have under the control of a data set. So how this prediction takes place? These are mainly three different methods by which prediction takes place. One is called clustering, one is called regression, and another is called classification. Now these are the very gross and very basic level tools which help us to understand that what is prediction. So what happens, I give you an example. There is a hard tissue. So during cancer surgery, what happens? There are two types of cancer. One cancer is called benign cancer, and another cancer is called malignant cancer. Now in benign cancer, what happens? There is a localized growth, which we usually call as tumor. So these are localized at a particular area, it is there. But there are some cancers which are not localized. they will be spreading from one tissue to another. That is called malignant cancer. So the robotic system should be able to identify which one is called malignant cancer and which one is called benign cancer. Depending on that only, it will change the dose of the radiotherapy. Okay, gamma ray or beta ray, that means what is ionizing radiations, which will destabilize the cancer. So by looking at the cancer, the automated system or the biomedical system should able to understand that which kind of cancer is this, and therefore some ability of prediction should be integrated in the system. So sir, go to the next slide. So these are the three basic methods through which prediction takes place. So if we go to the next level of prediction, we enter into something which is called generative prediction. So it is not only predicting, but it is also generating a code or a instruction which will help the robotic system to bend its arm and to project the radiation to a particular targeted tissue. Okay, for example, there are some deep tissue cancers, for example, bone or liver or something, where the radiation dose should be adjusted. So in that case, it should generate its own code, and then on the basis of that code, it will project its radiation intensity. I'll come back to those points later on. Sir, go to the next slide. So this is a classical snippet which will help you to understand, which is called unsupervised algorithm, as I have said. So in this case, what happens? The algorithm learns by the output itself. So unsupervised algorithms are many types. Out of that, one very interesting the algorithm type is this is called this thing. Hidden Markov model, very interesting, and it has been used in many these things, automated systems. Sir, I think okay. Okay. So in this, this is a simple snippet to make you understand that what are the different types of unsupervised algorithms which has been integrated into automated mechanical systems used in what do you call this? Used in medical devices. So go to the next slide, sir. So this is the opposite of it. That is, it's a supervised learning algorithms. These are four different types. I think they have. It has been shown. Yeah. Out of that, the thing which is present in the middle, that is naive Bayes algorithm or probabilistic classifier, has been used in many medical robotic system for giving it some kind of smartness. Okay, some kind of smartness in the sense, if there is a tool or if there is a method which will only able to do a small incision in the skin, not very deep, a very peripheral level of incision. In that case, these supervised learnings, that means this particular tool, which is a particular algorithm which is known as this naive Bayes, has been in very much use. I am afraid that I am not able to demonstrate the tool that we developed, the interactive tool on the what do you call this, the clinical trials that has already been taken place. But once given an opportunity, we'll able to demonstrate to you that how these technologies are giving some amount of smartness to the medical devices. Sir, go to the next slide, please. Here again, so what exactly happens is there is a thing called latent period. So latent period is needed for an internal machine to do many permutation combinations. So these robotic arms, which are used for many things, for example, taking a particular sample or doing a small robotic surgery, they sometimes have some latent space or some blank area, time lag, when they do some internal calculations. So in order to make you understand that how this thing happens, this particular snippet was added. Sir, go to the next one. So these are mainly integrating generative AI, and by using this generative AI, they are writing small codes which help them to take quick decisions. If you can remember some previous slide that I have demonstrated, one part is some decision making is also there. There is a small robotic arm, but there is some amount of decision making that it should have. This particular decision making ability it should have. So during this latent period, they generate a small code or a small, shall I say, a small program which will help them to take these decisions. So nowadays, these are not very streamlined. That means in day-to-day activity, we cannot use those things because it will become if something goes wrong, it will become dangerous. But in coming 5 to 10 years, robotic surgeries will be very common. Because no, I tell you, at that point of time, no, it will be become very costly to use human labor or human intelligence. So for repetitive tasks, these automated systems will be very helpful. Okay. For example, why these automated taxis were there? So it is in order to remove the human interaction, because many European countries, they have to import laborers from India or countries like that in order to basic transport. If you go to UK also, you will see that most of the buses run in London city are driven by Indians. Indians who might have migrated earlier, but but in European cities, you will see that most of the public transport are this thing by Indian, Bangladeshis, and Pakistanis. So that was the main reason behind that. Okay, so now, sir, coordinator, sir, I would request you to help me with this also. So there is a prompt given, sir. So I will request you to copy this prompt and paste it in Chat GPT, so that you can demonstrate a small thing that how prediction algorithm works. A very simple prediction we will do. No, sir. No, sir. In next one. Next one. This one. No, in this one, sir. The previous one. Here, sir, you can see there is a prompt written. So I request you to copy the whole prompt. Not everything. Not everything. Only the prompt, and paste it to ChatGPT, and ChatGPT will give you a Excel file. So keep on your these things, sir. I go to ChatGPT and then paste. Our participants can also do. Sir can paste the prompt to the chat box, so that some students or some participants, respected faculty members who are joining from their desktop, they can also do this small exercise. So now in the ChatGPT window, sir, please paste the prompt. Only the prompt area, otherwise it will get confused. Okay. Only the prompt, sir. Otherwise, no, it will go haywire and it will try to build something. Only the prompt, sir. Our participants can also do the exercise to get an idea that how prediction takes place. So this prediction will take place inside a robot. Very simple prediction only, but let's say how exactly this thing will take place. Okay, so now if you click run, then it will give you an Excel file. So I want you to open that Excel file, and then accordingly I'll tell you. Yeah, sir is requested to post the prompt. Post the prompt in the chat box so that our participants can also do. Okay, my name and ATAL FDP, this part, sir, you delete. Yeah, this part. Oh, great, sir. Thank you. Perfect. Sir, no, sir. The title of the FD, the title of my talk is also there in the blue font. That blue part also should be deleted, sir. This part, yes, sir. Otherwise it will not able to understand. Now this prompt should be pasted to both our participants as well as to ChatGPT. This is a very tiny task. Just give you an idea that how this thing, predictions takes place in medical robotic systems. Yes. Oh, yes, we got it. Yes, sir. Sir, have you got the Excel file? Ask it to generate the Excel file, sir. And then download the Excel file in your local desktop, and we will do it from there. Yeah. Yes. Sir, the Excel file, can you able to open? Yes, sir. Just hold on. I will just get.
Is it okay, sir? Hello. Hello. Devna sir, you're not audible. I think sir might have lost again connection. Just please wait.